yeah. Is it going? Oh, good. Okay, here we go. Intervals of increasing and decreasing. Okay. Read. Come on, do what you gotta do. Here we go. Okay. Like a sentence, you read the graph from left to right. It's going from left to right. Okay. From left to right, if the function is traveling in an upwards direction, it is increasing. And if it is traveling in a downwards direction, it is decreasing. Yeah? Okay. To describe these intervals, we look at the x-axis. Okay? All of the intervals are going to come from the x-axis. You might be tempted to pull from the y, because Ms. Fleck, it goes all the way up to 5 on the y. It's true, but what's the x-coordinate when it's at y5? That's what we're talking about for intervals of increasing, decreasing. What is she talking about? All right, here we go. We good? All right. So, for example, in a linear equation, right, so just diagramming this thing. First of all, right, the left side of the graph goes towards negative infinity, and the right side of the graph goes towards positive infinity. No big deal. No big deal. Okay. All right. In this function, if you were to travel along this graph, here's what the highlighter is for, right? If you were to travel along this graph, notice that it is always, hello, it is always going up. It's always going up, aka I word, increasing. This graph is continually increasing. So this is always increasing from left to right. One way you can write it is the graph is increasing from negative infinity to positive infinity, right? Or you can say it's increasing for all real numbers, right? Does the graph ever decrease? Heavens no! From left to right, it never goes down, so there is no decreasing. Not applicable. Sometimes graphs don't decrease. Okay. Yes, what family is this? Linear. Excellent. Okay. Next one. What family? What family? Absolute value. Okay. So here we go. In this graph, we're going to diagram this thing, right? So here's negative infinity and positive infinity. Okay. Here's the highlighter. All right. We're going to find the intervals where the graph increases and decreases. So from left to right, it starts by decreasing. It gets up to this point right here, right, where it decreases. When you get to that point, you want to look at the x value at that point, not at the y value. Okay? When it gets to the lowest point, pick out the x value, not the y value. Okay? After that point, highlighter, highlighter, it continues upwards, so it starts increasing. Okay? So you can say that from negative infinity to -6, the graph decreases. True? Right? So from like this way on, it decreases. Okay? And then from -6 to infinity, notice I didn't put the equal sign for the infinity part. Why? It can never equal infinity. Thank you, my dear. Yeah, it can never equal infinity. So you never put the equal sign for the infinity part. Okay? From -6 to infinity, the graph increases. Yay? Okay? So when you write this, you can put the infinity in, but it's also just good enough to say that x is greater than -6. If you want to read it backwards, it goes, for the increasing, x is greater than -6, and for the decreasing, x is less than or equal to -6. Abby? Question.
Should there be a line under the other one? What is equal greater than or equal to?
Yeah.
Like, another
Just right. So the other one is infinity, right? Can a number ever get to infinity? No. So the line will not have. There'll be no bar for infinity. Okay. All right. Good question. If you left it like this, by the way, I would take it. I would take it. But just so you know, this is normally how you would see it. Me. Okay. All right. Woo! What family? What family? Quadratic. Excellent. All right. Here we go. All right. Diagram. We have negative infinity and positive infinity on this side. Okay. From the left to the right, the graph starts by going. It goes down, right? And then it gets to a point, and then it starts going up again. What's that point? It's at 2. It starts going down at 2. Yay? So, from the left, it decreases from negative infinity to 2. Yay? And on the right, it increases from 2 to infinity. Okay? So let's clean it up. For my increasing, yeah, 2, and decreasing, yep, so you write that. Yay? Draw all over the graph, and that way you have a clean set. Okay? Let's try another one. What family? What family? Cubic. Whoa! This one's more fascinating. All right. Here we go. In this graph, from left to right, you start on the left side and notice it goes down, then up, and then down. Okay? It goes down, up, down. Okay. All right. Let's pull out all those intervals. Yay! So negative infinity is on the left, positive infinity is on the right. Okay? It goes down to a certain point. A lot of you are going to tell me that point is -8, which would be where the y value is, but we pull everything from the x-axis, so actually it goes down until it hits -2. So -2 is one of our critical points. Okay? Again, so from negative infinity to -2, it will decrease. Yay? Okay? Then from -2, it goes up again, up till you get to 1. So from -2 to -1, it will increase. Thank you. Yes. So we pull all of the stuff from which axis?
Oh.
Right. X-axis. I told you it was going to happen. It's okay. It's okay. Here we go. And then from -1 to infinity, it decreases again. Okay. So we have 1 increasing, 2 decreasing. To tell me where it increases, you just give me the endpoints and then x is in between that. Right? So it increases from -2 till 1. From -2 to 1, it increases. Okay. Decreasing. How do I write this? Yeah, so x is -infinity and -2, but without having to write infinity in there. Yeah, wouldn't you say that x is less than -2 at that point? Right? So x is less than or equal to -2. And over here, going towards infinity, x is greater than or equal to 1. Yeah, bless you. If you forget to put the equal to, I'm not gonna take it off. But just saying, it could be 1. Yay? Okie dokie. Next. All right. Woo! What family? What family? Quartic. Oh boy. Okay, here we go. This graph goes down, then up, and then it goes down for a little bit. Whoa. And then back up again. So it goes down, up. Yay. Okay, here we go. Here's negative infinity. Here's positive infinity. Okay. It goes down until it hits about, what is that? You did it again!
Oh,
X's! X's! Oh, thank you for doing that. You're being my example. She's just doing it to be example. All right. What is that? 2 point, not even, is it 5? Like 2.4, 2.3? Maybe. Hey, it's not even that close to the middle. Yeah, let's go 2.3. Yeah. Negative 2.3. Yay? Okay. So that's a critical point. Yeah. And then it goes up from that point till it's at about, okay, negative 0.6. I like it. Negative 0.6. That's a critical point. And then it goes down again until about, yeah, I like it. So this is at like 0.6, right? And then after that, it just goes on to up, right? So here we go. The graph starts out by decreasing. Then it increases. Yeah. And then it decreases again. And then for the rest of the graph, up to infinity, it will increase. I put that little, yay. Yes, pretend X is a number line. The rest of it's just another dimension, but all we're doing is describing a number line. What's going on here, right? Okay. All right, 2 increases. What's the first one? There, 2.3 less than or equal to X, less than or equal to, yeah, 0.6, and 0.6 to infinity, so therefore X has to be greater than or equal to 0.6. Ah! Yeah. Is that right? There's 2 increases. Right? Here to here, and then from 0.6 to infinity. True? Sure. Okay. Yeah. Not selling it. All right. The first decreasing. X is 2.3. Yeah. Yeah. And 0.6 less than or equal to less than or equal to 0.6. I like it a lot. Yeah. Yeah. Me? Have I lost anyone? Have I? I keep practicing. Yes, you do. This is better than domain and range. What? Oh, she said the D word. All right, here we go. Yeah, this isn't bad. No, it gets more interesting after this. All right. That's why I planned it for this day with the quiz, because this is not. Yeah. Okay. Here you go. Here you go. All right. What family? What family? It's quartic. All right. Ooh, I'm running out of things. So I'm gonna use green instead because there's not room for me. So it starts by going down, then up, then down, then up. Okay. Down, up, down, up. Sweet. Okay. Critical points. It gets down from negative infinity. Ooh, hello. It keeps going down till it hits -1. Then it travels up until it hits, she's got it. She's got it. Till it hits 1. Absolutely. Then it goes down again till it hits 3, and then we're at infinity. Ooh. Woo! Woo! Yeah. Yeah. Okay. So here we go. It started by going down here, so it's decreasing. Then between here and here, it increases. I'm just put I. Right? Then between here and here, it decreases again. And then the rest of the graph, it goes up. Okay. Let's describe it. It's so exciting. All right. Increasing.
-1 is less than or equal to x.
Amen. And?
X is greater than or equal to.
Yay! That's awesome. Adrian's got it. Adrian's got it. Okay. Increasing.
X is less than or equal to x.
Yeah.
1 is less than or equal to x.
Isn't it easy? Like when you just die, you just like read it from the thing. If you had drawn the graph, you could just read it from the graph. Yay. And I'll tell you, it's so excited. You feeling okay? Yeah? Okay. Okay. All right. So far, so good. Okay. Then it gets tricky. Not a big deal. Not a big deal. Here we go. What family? What family? Logarithmic, a vertical tail. It's a vertical tail. It's logarithmic. Do you see the tail, Miss Abby? See how it goes like straight down? There's like a little bit more down here, right? It's a vertical tail. All right, here we go. So from the left to the right, it's really not that bad. It's really not that bad. Go ahead, talk to me, Miss Adrian. It always increases. Exactly. This graph is just continually increasing. Okay? Problem is, it doesn't start at infinity. Right? It starts at no.
0.
Zero. You did it. You did it. All right. Here we go. Yes. It doesn't start at increasing at negative infinity. It starts at 0 and goes on from there. Okay. Here's the thing, though. 0 is like that barrier. You know how Adrian is actually floating on that chair? She'll never touch that chair ever, no matter how hard she tries. Right? You feel like it. I know. Life is crazy. Here we go. This will never touch 0. It'll never cross over 0. So when you're writing your inequality, this thing is just x is greater than 0 as opposed to not equal to. Right? It'll never touch 0. Okay? Does it ever decreases? Nope. Does it ever decrease? That's like bad English. All right. Ah. Yay? Yay. All right. You ready? What family? What family? Exponential. Horizontal tail.
Yeah.
Horizontal tail. Yes. Okay. Here we go. Still infinity, infinity. Right? And as you can see, go ahead.
About this.
Yes.
Like, as it goes down, we're
Yeah.
still always like increasing.
It's just always going down. So over there, this one has an asymptote. It never gets above 7. It'll never touch 7 either. So if you think about like concept of infinity, it never touches 7, so it's always going down. So it starts out like a trickle, like going down like real slow, and then bam, waterfall, drops. Yeah, 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 like a snake. Okay, okay, all right. So since this is always decreasing, there is no increasing. Yay?
But like the egg, if it was decreasing, wouldn't it be going that?
Oh wait, left to right, left to right. Okay, so if the graph is always increasing no matter what, how would we tell that?
It would be going. So to tell if it's increasing or decreasing,
Yeah.
why?
No. It's just tell if it's increasing or decreasing, you just look at the direction it's going. But then to describe it, you pull it from the x values.
Okay.
Okay? Has anybody got it? How do we write this? Where it's always decreasing. Nope.
What would be
X values. X values.
less than 3? No.
It hits what at 4?
The x is greater than 3.
Think about the x values. Just all the x values. It's always falling down. And all real numbers. Julia.
Get away.
It's all real numbers.
I'm so dead.
It's always falling down, aka it's always falling down from infinity to infinity, so all real numbers. Yes! Yes! All right, here we go. I'm going to give you approximately 10, 15 minutes. 10, 15 minutes. The paper on the back is your chance to practice. Work on your own first, and then we're going to compare our answers. Okay. All right, here we go. Hang on. Hang on. I'll be right there. Let me pause this flipping.